Okay, well, thank you very much, ladies and gentlemen. Um, I'm actually hoping to get my partner, Mr. John Lauder, to join us. He will be with us very shortly. But let me go ahead and get us started. It is 10 o'clock. Welcome to BNC's Virtual RF Microwave Lunch and Learn. My name is Junior Choe. I'm the RF and T&M Product Manager. And also, I have John Lauder. He should be with us shortly. Our chief engineer will be supporting us and giving us a quick demo of our sources here. Now, I see John Lauder has joined us.
Hello.
Hello, wave, wave. Okay, well, first, let me say thank you very much for taking the time to join us today, especially since many of us are working from home. I do hope that not only will this webinar be convenient for you, but that you'll come away with a little better understanding of, our equipment and how they can be a great solution for your applications. So to begin, well, let me quickly talk about an overview of our webcast here. This will be recorded. A link will be sent to all of our participants. Please feel free to, forward this to any colleagues that you may feel will benefit. There will be a Q&A chat session at the end of the presentation, but there is a chat box open on the bottom right-hand corner. Please feel free to enter any questions that you may have. We will try to tackle those at the end here, and if by chance we miss your question or maybe it's a little too specific or technical, we'll most definitely reach out to you directly and provide that support for you. And also, you may want to expand the presentation window for a better experience. There is a little button on the top right-hand corner with some arrows, 4 arrows spreading out. That'll just make it full screen, a much better visual if that is your preference. Let us begin. So before we get into the nitty-gritty, I'd like to touch on Berkeley Nucleonics, us as a company and how we've came to where we are today. Now, back in 1963, our founder, Mr. Mel Brown, he had introduced one of the world's first nuclear instrumentation modules, better known as NIMS. These are basically pulse generators designed for the nuclear experiments. And it was highly successful, so successful that it catapulted the growth of BNC. Now we have multiple digital delay generators, pulse generators of all different performance ranges in our lineup. You may have heard of our model 575 or 577. Those are considered the staples of the industry now for timing requirements. Today, we have 3 departments or 3 divisions of BNC, RF microwave, obviously, test and measurement with our delay generators and scopes and so forth. And then our nuclear division, we provide isotope identifiers, crystals, scintillators, personal radiation detection devices, and so forth. So basically, if there's a signal in this world, whether it's a microwave signal, electrical signal, or even radiation, we want to provide the capability to analyze those. So a little bit more about us. Our corporate headquarters are located here in San Rafael, California. We do have additional manufacturing facilities and sales offices throughout the U.S. and Europe, also Asia as well. This includes our vast network of local representatives. So if you are on the East Coast, we have our local representative, Advanced Technical Marketing, who can also provide additional support, on-site support, and even possibly a demo unit for your evaluation. Now, as I mentioned earlier about our pulse generators and how that's really helped our growth, similarly, that can be said about our RF division as well. Now, about 12 years ago, we decided to enter the market by offering very high-performing but cost-effective signal sources, and was highly successful. That introduction has brought us to where we are today. Now we have a full breadth of product lines, going from low frequency all the way up to 40, of signal sources, synthesizers, and even our phase noise tester. So today's agenda, we'll be talking about phase noise, the methods to measure phase noise. We'll also have a quick demonstration of our ATE, or Advanced or Automated Testing Environment. John Lauder will assist us there and give us a quick real-time demo of that. And also he will give us a quick demo of the GUI software that we provide for you and all the different features within. Then we'll move on to signal sources with the focus on antenna testing. Of course, highlighting our signal sources and how they can fit in. And then finally, our new product, almost ready to be launched here, our vector signal generator coming down the pike. So, what is phase noise? Most of you may already know, but the definition of this is basically the frequency stability of a signal, more specifically within an oscillator. So if you can imagine, let's say a cell phone connection, if it's noisy or you're having any kind of background noise, a phase noise has a lot to do with that. Similarly, for communication links with radar or satellite, to have the best communication, you want to have the lowest phase noise possible, and that is why it's so important. The best communications require the best phase noise. Now, if you look at the visuals to the right here, the first visual is the ideal signal, or quote-unquote ideal signal. As you can see, it's a very clean sine wave. The spectral line below is very straight and clean as well, nominal amplitude, nominal frequency. But many of you know that the ideal signal is not really what you will attain in the real world. So if you look to the right of that, this is what you will normally see. Random amplitude changes or fluctuations, random phase changes. And the sine wave there completely shows that. Below it, the spectral line is not as straight anymore. So with that, we need to determine what is the value of that phase noise, right? Especially for many of our customers, manufacturers of devices that require ultra low phase noise, you need a way to measure that. So there are a few different ways to measure phase noise. The first is the oldest and most simplest method, using a spectrum analyzer. You directly connect your DUT to the spec-an and go ahead and start measuring the phase noise. But there are some limitations, and the main limitation here is that noise floor. Your spectrum analyzer must have a noise floor that is lower than the device that you are testing. Dynamic range as well. The carrier signal is not suppressed, and there's no way to distinguish the AM from PM noise, which is quite important, especially for residual measurements. The second way to measure phase noise is the phase detector technique. Now, basically, your device under test, that signal is mixed with a reference signal, usually within the phase noise tester itself. And it is the same frequency as your DUT, and we will use a phase detector mixer. Now, there are some limitations to this as well. Again, that reference source must have lower phase noise than your DUT. That PLL also forms a high-pass filter to compensate for those fluctuations, and the PLL loop bandwidth must be substantially lower than the lowest noise frequency. This is partly what our phase noise tester solution offers. I will get into how we tackle these limitations in the next couple of slides. The third way to measure phase noise is IQ demodulation. And you're basically down converting your signal into baseband and measure it directly with an analog to digital converter. A limitation, if you would even call it a limitation, the dynamic range. You will need multiple ADCs built within your unit to measure simultaneously. That will inherently raise the cost of the unit. And again, it may not be a limitation to you if you do not have a limit to your budget. But from my knowledge, from searching the market, there's only one manufacturer that offers this solution. It is not Keysight. It is not us. I will let you take the wild guess. Now, cross-correlation. Now, this is how we tackle the limitations of the phase detector technique. And as I mentioned before, phase detector technique, you are mixing your DUT signal to an independent reference source. Now, that reference source is going to add a little bit of noise to your signal. So how do we account for that, right? So in our case, we use a cross-correlation method by having two channels or two independent reference sources with the phase detector circuits. So in that way, you can average away the additional noise from those reference sources by cross-correlating, and that can improve your noise measurements up to about 20 dB over the single channel quadrature method. This is a tried and true method again. As you may already know, many manufacturers offer this type of solution. Here's a quick visual of what we were just speaking of. So as you can see, your signal source under test, or your DUT, that signal will be split into two channels. Each channel has its own reference source. Those are mixed in with your DUT signal. And then they will be outputted to a digital signal processing unit. This is where the cross-correlation happens, or quote unquote, the magic happens. All of the excess noise from your reference sources will be averaged away. So the number of correlations will determine the type of improvements that you can expect. So for example, at the bottom you see, let's say for 10 correlations, you can expect about a 5 dB improvement. 10,000 correlations, you can expect about a 20 dB improvement. So there are a couple of different types of measurement capabilities with our unit. The most main common measurement is the absolute. So absolute phase noise is basically the signal source itself. So for example, a signal generator with VCOs, OCXOs, TCXOs. These are basically the signals, where the signals are coming from. So that is an absolute measurement when you are trying to measure the phase noise of these types of signals. Again, the most common way or the common necessity. But we also have the capability to offer additive or residual measurements. And this is basically testing devices where that signal source or the signal passes through. So for example, an amplifier or a transmitter or mixer, all of these devices have that signal passing through, but these devices will also add their own phase noise to that signal. So it is quite important for the manufacturers of the devices to know exactly what that phase noise value is, and to be able to spec that for their devices. So a quick visual of what a setup could look like. In this case, let's say an amplifier, your DUT. It also has the phase shifters there to make sure you are within quadrature before you can do your measurement, and using an oscillator for your external reference. Another way to set up as well, again, this is an amplifier being split to a phase shifter using your signal generator for the AM reference. Yes, phase shifter again to make sure you're within quadrature before you can do your measurements. But there's quite a different ways to set up. It would all depend on your preference and the type of DUT that you are trying to test. Okay, and this is a quick snapshot of what the GUI would look like for additive or residual measurements. John Lauder, again, will get into this in more depth in real time to show you a little example of what it would look like, along with some other features besides the ATE. Okay, so moving on, internal and external references. So as I mentioned before, our unit provides two internal references built in. And basically, internal references are synthesizers. They are a signal source itself. But there are some, I would say, components or some limitations to that will add some noise. So when I say that, these internal references must have some flexibility to attain different frequencies. So for example, our PNT goes up to 40 gigs. Our internal references must also be able to reach 40 gigs. In order to do that, there's going to be some components in there that's going to add some noise. And if you would like to mitigate that and have the lowest noise possible, using an external reference may be a better choice. So for example, if you were to use an OCXO or a VCO at a certain frequency, that will not have any type of components there to add any type of noise, you'll have a much cleaner signal. So in essence, using an external reference, again, an OCXO or VCO at a specific frequency will provide you with a much lower noise floor. So that could be another way, another solution for you if you have an ultra low device that needs some accurate measurements. Okay, so moving on to our phase noise tester in itself, we do have 3 models available. The first is the 7070 going up to 7 gigs. The second is the 7300 going up to 26 gigs. And finally, our flagship, our 7340, going up to 40 gigs. And of course, a host of different measurement capabilities and features, both additive and absolute measurements. Of course, amplitude as well. And then we have a very popular feature in there, the one-step VCO characterization, where you can set all of your parameters, all the voltages, and then easy plug and play. Very popular with our oscillator manufacturers. Moving on, keeping on the PNT here. It's completely PC based. So as you can tell from the pic here, there is no front panel, no screen, no buttons. Everything is PC based through the GUI software that we provide for you. Connected through LAN, USB, or even GPIB. And one of the main reasons that we offer it this way is that it increases reliability. The front panels with the buttons and the screens, they will start to malfunction over time. So, we not only is it going to increase that reliability by removing that, but we can reduce the cost as well. And we do know that's quite important for many of our customers. Low instrument floor, this might be one of the most important specs of our unit, going down to minus 190 dBc per hertz. Again, if your DUT has a lower noise floor than a device that you are trying to measure it with, you will not get the results that you require. Flexible external references, as we mentioned before. You have some built-in DC supply voltages, 3 independent tuning voltages that really helps you with the VCO characterization. You even have an external trigger input if you have if you would like to get the unit started with a different device. And it's quite lightweight. It's about 24 pounds, much lighter than the traditional benchtops that you see out there. Where you would require a cart or a dolly to move it around from one location to the next. Our guy here, you can just easily carry and move it to any location that you would like. It is portable. And we did touch on the key functions, but I would like to highlight again the amplitude noise measurement. This is a very good feature. Not many on the market will provide this for you, but again, this is standard with our unit, and a very, very great feature that many people request. And absolute measurement, CW and pulse measurement modes. Also there to lock on the high drift devices, but always with internal references. So what is a lunch and learn without the lunch? You know what, better yet, where is the beef? Now, we call this a lunch and learn, and I'm sure you guys are all wondering, how are you going to provide us lunch? How can you even call this a lunch and learn? Well, we've thought of this, and in our appreciation for you joining us today, we will send you a gift card of a local restaurant in your neighborhood, along with a t-shirt of the size of your choice. I don't know what restaurant it is at the moment, but I do promise you it will not be Wendy's. So with that said, I'm going to have a little button pop up here. A button should have popped up in front of you. If you were to just click on that, that will take you to our contact form. All you need to do is fill in your information, your t-shirt size, let us know where to send the t-shirt and the gift card. And of course, if you have any questions about your applications or equipment, anything, of course, please feel free to add that in there and we will support you. So, moving on. ATE, so besides our benchtop applications with the GUI, we also have the capability to provide a solution for automated testing by using skipping commands through USB, GPIB, or even LAN, all different types of languages as well, VBA, Java, MATLAB, LabVIEW, and most recently we've added Python. So with that said, I am going to pass this over to John Lauder. He is going to do a quick demonstration of ATE and then go into our GUI in a real-time demo. Thank you, John. Go ahead. He's trying. He'll be in here in just 1 second. Maybe he's having a little bit of technical difficulties. There you are.
Thank you, everyone. Again, this is John. And as Junior mentioned earlier, let me share my screen. As Junior mentioned earlier, that we will do a quick demo on the PNT on the AT mode. But before that, let's do a quick demo on the PNT GUI. The PNT GUI is designed for simplicity and ease of use. Functions are split into different tabs: absolute phase noise, additive or residual phase noise, amplitude noise, absolute phase noise for high drift oscillators like YIG, DRO, and so oscillators, FFT analyzer, transient analyzer, time stability, VCO characterization, and spectrum monitoring. As I mentioned, the GUI is very easy to use. And for you to make measurement, you simply connect to a device. I have a USB device. So it's connected, and you set your parameters. You set your offset. You set your correlations. And simply click measure. So that's making some measurements. It will take about 20 seconds to make about 10 correlations from 10 Hertz offset to 40 megahertz offset. Then you can just add that measurement. Once you have the measurement, you can again analyze the phase noise. You can add markers. You can add the offsets. It shows spurs and some other data regarding your oscillators. That's how to make measurement on the graphical user interface. Now going back to the ATA measurement, disconnect that. This is written in Python. Again, this is the newest code that we have. The first thing you do is pretty much connect to the device, which again, I have a USB instrument. Reset the device to make sure you have the factory default and you don't make conflicts on the settings. You activate the frequency search and power search automatically. And the next part is to set the measurement parameters. Here you set the number of averages, number of correlations, and the start of offsets and the end offsets. At the end, and then you're gonna have to initiate the device, which basically same as clicking the measure button and it's showing, and then you gather the data using these commands. Let's try to save this, run this app using the F5 button. And there's your phase noise measurements. Good. Let me give you back to Junior to talk about the signal generators.
Thank you, John. Okay, so let us dive into our signal sources now that we have already presented our phase noise tester. So quickly, let us talk about the different types of signal sources available on the market. The first one is the continuous wave or CWLO source, the most commonly requested type of solution. The second would be analog signal generators with some modulation capabilities. Finally, the vector signal generators capable of both analog and digital modulation. Now, the quote-unquote golden source in a lab setting is usually a high-performance, low-phase noise CW source, or even possibly an analog signal, again, with some very low-phase noise. The most functional, again, is the vector signal generator. It has all of the modulation capabilities, sometimes including pulse modulation. So we mentioned antenna measurements, and how we fit in. Let me go over the basics of the antenna measurement system. So the first part of the antenna measurement system is the shielded chamber with positioning system. The position controller, which is the interface to that positioning system. Signal source, obviously, for example, a Berkeley Nucleonics unit with fast switching. You see that I've highlighted fast switching, which I will get into why that is important, especially in antenna measurements in the next couple of slides. The receiving system, usually it's a combination of VNA, a spectrum analyzer, frequency converter. And then finally, the software. Many consider this the most important piece of the puzzle, as it is the heart of your antenna measurement system, being able to control every component. Now, this is a quick visual of what a basic antenna measurement system would look like, the setup. Now, there are a few different applications, whether it's near field for the shorter distances, far field, usually outdoors for the very long distances, and then RCS or radar cross-section measurements for, normally vehicles or objects where you would need to test how well radar can detect those. Now, in this visual here, as you can see, there's a signal source on the transmitting side that will go to the antenna under test. At the same time, that will also be referenced to the receiver, usually the VNA combo. And just to make sure that frequency is the same when it gets to the receiving side. And then the probe antenna on the receiving side also for EMI or electromagnetic field analyzation. So we talked about the shielded chamber with positioning system. That is the first piece of the puzzle. This is a quick snapshot here of what a chamber would look like. As you can see on the walls and the floors and the ceiling, that is electromagnetic absorbing material to mitigate or suppress any type of reflections, any type of any other signals that may interfere. So you want to have the cleanest signal going to your antenna. Now to the right here is a positioner, a mechanical positioner. This is what the antenna gets mounted on top of. Now, before I mentioned fast switching, why that is important to have fast switching in your signal sources. So, for example, if you have your antenna on top of this positioner. And this positioner will turn that antenna 360 degrees at the increments of your choice. So if you have a fast switching signal source, that is going to be highly important for you, as you will be able to do many more measurements in the same amount of time. So for example, that antenna is turning 360 degrees. Let's say you're going to have it stop in 1 degree increments and do quick measurements. Each increment, you can cover many, many more frequencies with that faster switching speed, again, in the same amount of time. So this is highly critical, highly important for antenna manufacturers. Not only does it help you with more measurement capabilities, but it increases your productivity as well. So let us dive into our solutions. The first is our low noise microwave signal synthesizer. We have the model 845 or the 865-M. Can go up to 40 gigs, excellent phase noise again, and this is something that we stress here at BNC with all of our RF equipment, as again, phase noise is highly important for clean communication. Very high power output as well, plus 23 dB in that fast switching speed of 25 microseconds. Now I'm going to switch to my camera here so I can kind of show you what to expect, what you would expect the actual unit to look like. So as you can see, the synthesizer here is very small, compact, very lightweight. I would say it weighs about 2 pounds. You have your RF out right here, SMA connector. You have some BNC connectors for your reference in and out, pulse, and your trigger. In the back, you have your communication port, whether it's LAN or USB. And then you have your power supply connector. So again, very lightweight, easy to move from one location to the other, and also even integratable into your solution. So with that said, let me go ahead and switch back to an example of how you can integrate our synthesizer into your solution. Now this is a picture of a product from one of our customers, antenna manufacturer. This is basically their VNA system, the receiving system of that the antenna measurement total system. You can see in there our low noise synthesizer being integrated in there very nicely into their chassis. Again, many different uses for this, including integration. So we talked about the synthesizers, and maybe you require, a little bit more functionality and a smaller size. Well, this is where our OEM solution comes in. So what you see here is our 845 or 865-OEM. Basically the boards from our benchtop signal generators. Again, high output power up to plus 27 dB at 1 gigs, up to 40 gigs, vast frequency range, and again, excellent phase noise performance, because as we know, this is one of the most important specs our customers require. Resolution is very fine. Then again, that switching speed, very important at 30 microseconds. And all of our signal generators can be phase locked for multiple units. Another quick snapshot of a customer of ours using our OEM solution into their signal source product. In their case, this is more of a 2U slim chassis. And as you can see, our OEM, it slots in there very nicely. And now they can offer the performance of our OEM solution as their signal source offering. Again, plus 27 power, excellent phase noise, all of the features you would expect from our benchtop will be there for your on the board level. So speaking of the benchtops, this is exactly what it would look like. Great specs again, going with the 40 gigs, in this case even 20 microsecond switching speeds with the fast switching option. a host of modulation capabilities, including pulse, AM, FM, and PM. And we can always going to stress the phase noise. Very, very, very good. I'm going to switch back to my camera so I can show you real time what this guy would look like. So hopefully you can see it on the video, not being too choppy. But as you can see, not the traditional benchtop that you would expect from the market. A full-on signal generator this small, I would say it's the size of a lunchbox and weighs about 6 pounds. So you would not have any problems, moving from one location to the other. It has a handle for easy portability. It's actually designed for field use as well. Just a quick show off here of a new bumper that we've created for this unit. So as you can see, easy bumper to just stick on to the front and the back to give you a little bit more ruggedization, especially out in the field. Boom, boom. Kind of like a bumper for your cell phone as well. And we have one for the front, and you can put one on the back. Easily take out into the field. And in conjunction with the internal battery option, it's a true standalone solution for field use. You will not need an additional power supply. Right. So just to show off, really quick, just to show off, the different connectors. You have your RF out. That again is an SMA connector. You have your front panel. You can set all your parameters through the front panel. But again, we also still provide the GUI if you wanted to control this unit that way, remotely. Connectors in the back, BNC connectors for your reference in and out, trigger, and so forth. But again, very lightweight, very portable, highly popular device, especially for field use. But again, put it on your bench and it will have the performance that you require. Okay, so I know you guys are sick of looking at my face, so bam, let's switch over to our multi-channels. Now, this is very exciting for us as well. You can have up to 8 channels in one unit. It's usually a slim 1U enclosure, and that can fit up to 4 channels. But if you required more than 4, then we would switch over to the same enclosure as our PNT. And in this case, that is an 8-channel unit. Again, every channel going up to 40 gigs. You can mix and match frequencies if you require. And your switching time, again, going down to 25 micro. All of the outputs are phase coherent. As we know, that is quite important for many of our customers. And we're almost at the end here. We are very excited to announce our Model 875 vector signal generator. Matter of fact, by the end of this month, by the end of June, we should have our first iteration available. It is the 4 gig model. We'll have, the host of modulation capabilities, especially the IQ digital, pulse modulation, ultra high data rates, deep internal memory. I believe you will have 9 different storage slots, and of course, excellent phase noise. And this is quite a specialized feature as well, the wideband linear chirp. So we are almost done, but before we finish, I must highlight our new BNC Academy. We are very, very excited about this. We have courses now, whether it's on the RF side or test and measurement side or the nuclear side. And we can actually offer you a code for you to access these courses completely free. So with that said, let me go ahead and send you this code. It is basically the word Berkeley. Now, I'm going to share my screen really quick. As soon as the button goes away, I'm going to share my screen and show you exactly where that's going to take you. Okay. Okay, so if you clicked on that button that was on your screen, it would have taken you to this page you see here. This is our RF Academy. And if you scroll down, you'll see the featured courses. Let's take a look at all the courses here. So from nuclear to RF, the RF Bootcamp is a basic course on RF, very good for students, maybe some new technicians, or possibly you just would like a refresher yourself. And a great way to kill some time as well, since many of us are working from home. Let's see. In this case, let me go ahead and click this. This is a phase noise measurement course. It's normally $99, but again, with the code that I provided for you, it'll be completely free. So you will see the curriculum below, all the different chapters and the different topics. And I will show you how to apply that coupon. So you would just click enroll in the course for $99. It should take you to a page. Right at the top, it'll say order summary. And then there's a button right below the picture. It says add coupon, right? You would click on that, type in Berkeley, all in caps, and it'll take away that $99, make it $0. You have full access to this course. Now, please remember, this code will apply for any of these courses. So even if you are an RF engineer and maybe interested in a little bit of nuclear, please feel free. Use a code and go into a nuclear course. We'd love to get everyone's feedback, and that's quite important to us, as these academies or these courses are quite new. We are going to rely on your feedback. Any suggestions on improvements, any mistakes, if there are any in there, we want to know, and we appreciate you taking the time to give us that feedback. So please do. Okay. So that will wrap it up for us. I appreciate you guys being with us today. Hopefully you came away with a little bit of better understanding of BNC and the types of solutions that we offer. I guess we can kind of dive into our Q&A. So I am going to look at the chat box here, see what type of questions that we have, and hopefully we can answer some of these for you. Do most customers use a signal generator to upconvert a baseband signal? Thank you, Mr. David Kuhn. Thank you. Mr. John Lauder, I'm going to refer this question over to you. So if you wouldn't mind jumping in.
Yes, thank you for the question, Mr. Kuhn. Yes, most they use mostly mixers and with a signal gen to convert some signals from baseband signals to some other signals as well.
What's a common application used with your PNTs? Well, the most common application is the absolute measurements. We have many oscillator manufacturers that are using our phase noise tester specifically for that. We also understand many are coming from a certain platform that they've been using for a very, very long time, a certain type of software, and they expect a certain visual, right? So we've thought of that as well, and our design of our PNT, we try to make it as smooth as a smooth transition as possible for you coming from a different platform. But the most requested use is for absolute measurements. But of course, we do have many amplifier manufacturers that are using our PNT for additive residual measurements. Power range for the Model 865. Well, we do have, it can stretch down to minus 120 all the way to plus 25. Again, we have a PE4 option that extends that power range. So, and also if you needed the higher power, we have higher power options for some of our signal generators as well. So if you have a certain requirement that that needs to be filled, please feel free to reach out, and you can reach out to me directly. You can call the number on your screen right there and just ask for Junior. I'm happy to support you. John Lauder is here for you, and the rest of our sales team can provide support as well. I see some more questions being typed right now, but I think there might be a little bit of technical issues with the chat box. I don't know if it's freezing or whatnot. Whoa, now there are a million questions incoming at one time. I've used a 5052 for years. How long has a 7300 been out on the market? I will estimate at about 9 or 10 years. We've had this phase noise tester. At first, we offered it at a very, very lower frequency. And then I would say maybe 4 or 5 years ago, we started offering the 26 gig version. And then most recently, we have upped it to 40 gigs. Can you tell us a little more about your pulse phase noise measurements? And do the pulse need to have timing correlated with the underlying sinusoid? John, I'll let you answer that one.
This is a question for Mr. Lucas. I'm not sure if you're talking about the pulse measurement. Yes, we can do a pulse measurement with the, let me share my screen quickly. On the GUI, let me connect that to a device. On the GUI, there's a pulse mode that you can activate and measure a pulse measurement. Is that what you meant by underlying pulse and sign?
I see Mr. Lucas is typing. But definitely capable of pulse measurements at all different duty cycles. Oh, the way you create a pulse measurement is we chop a sinusoid.
It's pretty much the same thing. Yeah, it's a pulse measurement. As you can see on my screen, we also have a burst analysis, so that if you have a very narrow pulse, it can still make a measurement while the others can't. Though this is not a single sideband measurement, it's a good way to measure a very narrow pulse width. Next question, Junior.
I think I just may be having some technical problems here. Hang on. I think that may be it for the questions. Hopefully, again, this was somewhat informative for you on how, our products can be a solution for you. If you have any, direct questions, more technical on how we can help, please do feel free to contact us directly. Let me go back to the contact form here. Email, our website. We have a contact form there. You can call the number, and you can easily ask for myself, Junior Choe, John Lauder, or anyone who on our sales team can provide some support for you. But yes, please feel free. And even if your application is having, if you run across an obstacle, a challenge, and you would like maybe a third party to take a look and maybe give you some suggestions, we are more than happy. So please do come to us with your problems. We will see how we can solve them for you. But I guess this would, wrap it up right now. Thank you very much for, joining us today. Again, please feel free to reach out. Any questions, concerns. Have a great day. Have a great weekend. Hopefully you're allowed to go outside in the near future and enjoy the fresh air. No more quarantine. Have a great day, everyone. Bye-bye. Bye,
Bye.
John Lauder.
See you guys.